Hi, ladies, Mr. Sullivan. Today is April 8th. Oh, it says it right here. Even though it's Monday, April 5th, as you can tell right here. I'm recording it now. Okay, so let's begin. So today's learning target is I can perform a dilation on a given set of ordered pairs and plot the points on the coordinate plane. So this is actually a very smooth sailing lesson. There's really not that much thinking as long as you know how to multiply and plot some points. We learned about the basics of dilations at the beginning of the year in our first transformation unit. We didn't really cover a lot of them, but we did see them appear in our basic transformations. So you did learn the basics. So a dilation is a transformation that produces an image that has the same shape as the original. So that means if I start with a triangle, I'm going to end with a triangle. If I start with a square, I'm going to end with a square. If I start with a smiley face, I would hope to end with a smiley face. Just kidding. I'll definitely end with a smiley face. But it will always be a different size, so it can be bigger or it can be smaller. A dilation that creates a larger image is called an enlargement. Makes sense. A dilation that creates a smaller image is a reduction. A dilation stretches or shrinks the original image. So that's the lingo we're going to be using. Okay. Practice. Graph the image of triangle ABC under the dilation D of 2 sub 2. So what we're going to do is we're going to actually plot those points right here. So we're going to plot a -4, 2. So I'm going to go out 4, up 2. So 1, 2, 3, 4, 1, 2. I'm going to plot the point -2, 3. So 1, 2, 1, 2, 3. And I'm going to plot C3, 1. So go out 3, 1, 2, 3, up 1. So C's right here. And now I'm going to connect those points like so. Okay, that didn't come out as nice as I wanted it to. 1 second. Much better. And if you look, I have a triangle. It's not the greatest triangle, but it's a triangle. And now what we want to do a dilation of 2. So when we do a dilation, we are going to be multiplying. So what I like to do, not sure what Miss Colorundo likes to do, but I should ask her, is I like to do this. I basically rewrite dilation of 2 above each arrow. And that lets me know that I'm going to be multiplying each of those coordinates by a 2. So I get A prime, B prime, and I also get C prime. And we need to use that prime notation because it means we're making a new image. So when I look at this and I multiply -4 by 2, I get -8. What's 2 times 2? It's 4. So I'm basically just multiplying by 2, multiplying by 2. Now when I do B prime, I do -2 times 2, which is -4. And then I do 3 times 2, which is a 6. So I now have the point -4, 6. And then I need to do C prime. So I'm going to multiply 3 and 1 by 2, and I get 6 and 2. So now I'm going to plot these points. I'm going to use pink this time. But I'm actually going to use red to label the points. So I'm going to go out 8, up 4. So out 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So I'm going to plot a point right about here. And that is A prime. Now I'm going to plot B prime, which is -4, 6. So I go out 4, so 1, 2, 3, 4, up 6. 1, 2, 3, 4, 5, 6. So right about here. And that is B prime, B prime. Now I'm going to plot C prime, which is 6, 2. So I go out 6, so 1, 2, 3, 4, 5, 6, up 2, 1, 2. So right about here. And that's C prime. Now what I'm going to do is I'm going to connect those with a nice pink line. Good. Good. And good. And that's my triangle. So I start with a triangle and I end it with a triangle. Now, determine the slope of all sides of both triangles. So what we're going to do is we're going to actually find the slope of AB, A prime, B prime, AC, A prime, C prime, and BC, B prime, C prime. I'm not going to use the slope formula. I'm just going to do slope is equal to rise over run. So I'm literally just going to calculate the rise and the run of each. So if I want to do the slope of AB, I want to find the slope of this right here. So if I look, I'm rising 1 and I'm running 1, 2. So my slope is going to be 1/2. If I do the slope of AC, I go down 1 and to the right 1, 2, 3, 4, 5, 6, 7. So my slope is -1/7. Now if I want to do the slope of BC, I start at B and go to C. So I go down 1, 2, 1, 2, 3, 4, 5. So my slope is -2/5. Now let's find the slope of A prime, B prime. Start at A, go up 1, 2, 1, 2, 3, 4. So my slope is 2/4. But here's the issue. 2/4 I can reduce. I can divide by a 2 on the numerator and divide by a 2 on my denominator. When I divide by 2 and divide by 2, I get 1/2. So my slope is 1/2. Wonder what's going on. Now I do the slope of A prime, C prime. So I start at A prime and go to C prime, which is right over here. So I go down 1, 2, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I go down 2, right 14. But if you look, I can divide by 2 again. So I get -1/7. I wonder what's going on. Wonder if you notice something. Now I do the slope of B prime, C prime. So I start at B prime and then go to C prime. So I go down 1, 2, 3, 4. Yeah, 4. And I go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go down 4, right 10. And if you look, I can reduce that again. I can divide by 2, divide by 2. -4 divided by 2 is -2. 10 divided by 2 is 5. So I get a -2/5. So if you look, the slope of AB is 1/2. The slope of A prime, B prime is 1/2. Slope of AC is -1/7. The slope of A prime, C prime is -1/7. This is getting weird. The slope of BC is -2/5, and the slope of B prime, C prime is also -2/5. So ladies, what that means is when I dilate an object or a figure or a point or whatever, it is going to be parallel to the original image. So what's going on is that I can actually say that whenever I dilate something, the new image or the new segments will be parallel to its original segments. They will never intersect. So if you look, A prime, B prime will never intersect AB. AC would never intersect A prime, C prime, and so forth. And that's going to pop up. And that's a very big idea that comes with dilations that we need to really root into ourselves. Okay, let's go into the try these. These are very similar to your delta math problems that you're going to be completing later on. Question number 1. What are the coordinates of the image of the point 2, -5 under the dilation D, -5? So what we're going to be doing is we simply just want to multiply our x and y coordinates by -5. So what I like to do, I hope Miss Colorundo likes to do this, is I write down my 2, -5, and I'm going to draw an arrow. I like to draw an arrow, and I do D, -5. And what that means is I'm going to multiply my 2 by -5 and my -5 by -5. So 2 times -5 is -10, and -5 times -5 is 25. And this is your final answer. Number 2, find the image of 6, -9 under the dilation 2/3. So what I'm going to do is I'm going to rewrite my 6, -9. And I'm going to just do 6 times 2/3. I would just type this into my calculator, or I can do it in my head. Here's how you would do it in your head. If I want to do 6 times 2/3, I do 6 times 2, which is 12, and 12 divided by 3, which is 4. So this becomes a 4. And now I do negative 9 times 2, which is negative 18, and negative 18 divided by 3 is negative 6. So I get 4, negative 6 as my final answer. Number 3, find the scale factor for the dilation that maps negative 1, 6 onto 4, negative 24. So I'm going to write negative 1, 6. And I ended up with 4, negative 24. So what we need to do is we just need to basically set up an equation. I'm not going to use x or y. I'm going to actually use k, because k is dilation language. It's a scale factor. So let's look at this example. So if I do this problem, I want to figure out what do I multiply negative 1 by to get to 4. So I'm going to do negative 1 times k is equal to 4. How do I get rid of that multiply by negative 1? I divide by negative 1. What's 4 divided by negative 1? It's negative 4. So I can say my scale factor is negative 4. And to check that, I just do negative 1 times negative 4, which is 4, 6 times negative 4, which is negative 24. Okay, so sorry for the mishap. Find the scale factor for the dilation that maps negative 4, 6 onto negative 10, 15. So what I'm going to do is I'm going to rewrite this the exact same procedure. So I'm going to write negative 4, 6, negative 10, 15. And what we want to do is we want to figure out what do I multiply my negative 4 by to get to a negative 10. So I'm going to write down negative 4k equals negative 10. And I'm going to ask that you do not write x or y, because we're not solving for x, we're not solving for y, we're solving for our scale factor. So please use the proper lingo. So I'm going to divide both sides of my equation by a negative 4. When I do that, I get 2.5. So what I can say is my scale factor is 2.5. And to check it, negative 4 times 2.5 is negative 10. 6 times 2.5 is 15. And that's it. If you have any questions, please email myself or Miss Colorundo. And don't forget to do your delta math. Have a great day, ladies.